Today, we're gonna have some fun because I'm gonna try to tip this forklift over. Well, maybe not quite, but I do need to build a forklift attachment, typically called a jib, for an upcoming job I'm doing.
What exactly is a forklift jib? It usually has a hook on the end and can replace a crane in some instances. The downside to a jib is that it reduces the load capacity, which also increases the likelihood of a forklift tip over. So here's my design. First, I need a base that's going to be able to attach to the forklift. I need to have a special tall mast that's going to give me the clearance and the reach that I need for my project. So I need to elevate that about 8 feet. The next design criteria is that a mast that moves in and out, and maybe some sort of wiggly thing on the end that'll help me position my work where I need it.
You can't really buy something like this. I've looked, so we're going to just build it with the materials I have around the shop. So let's get started.
I'm going to be using some 3x8 rectangle tubing with a 3/8 wall thickness for the project. And I picked this stuff up at the local steel recycler, so it's pretty reasonably priced. It's kind of like a big treasure hunt every time you go there. You never know what you're going to find, but I always end up leaving with something. One negative to getting recycled material is the rust. I'm going to have to grind every joint where it's going to be welded, so that's going to slow me down a little bit, but for the price, I can work through that. I need 2 tubes that are going to slip over the forks, and this is going to be the base or the foundation I can weld everything on top of. I'm choosing to spread the forks pretty wide to give me the maximum stability. And then I'm welding it all together with some 045 dual shield flex core wire. Once I got everything all squared up with the monster square, I installed what I call a tack bar. This is going to keep the legs at a set distance. That way when I go to erect it, it's going to land exactly where I want it. It's time to remove the tack bar, and a neat little trick is if you only weld on one side of the bar, you can hit it off with a hammer pretty easily. Adding a gusset for a little bit of stability isn't a bad idea either.
The next step is welding the jib portion on top of this mast. Well, I take that back. I was going to do that, but I've now decided to make the jib adjustable. So it's going to slide like a piece of receiver tubing on top of some straps that will weld onto this. So let's get the straps on, and then we can slide the mast in and see how it looks from there. So let's do that next.
I'm making the straps out of some 1/2-inch plate, and the water jet's just going to slice and dice them up to the 8-inch wide pieces that I need, but I could have also used some 8-inch flat bar if I would have had that too. I need to turn this big, thick, heavy plate into a U-shape, and I find fabricating it is much easier than in trying to bend this into shape. This really helps me adjust the clearances just right. That way it's not too loose nor too tight when we go to slip the jib in.
To space those plates apart, I'm using the magnetic 123 blocks and whatever spacer I want to get the distance. Everything from 3/16, 1-inch, 1/2, 3/8, all the way down to the thin shims, 1/32, 1/8, 1/16. So now I can choose exactly how far I want those plates to be spaced apart with the shims. Now I'm not searching around cutting a block to do this. I can just click everything together, set the distance, and off we go.
These plates are extremely heavy, so I'm using the monster square with the long pins to help keep things square and to reach around that really long radius of the tube steel.
Well, what do you think? This is my idea for the jib. Well, it's not going to be made out of wood, obviously, but it'll be made out of the same tube steel as this machine. But what my application is needing is some maneuverability out on the end because I'm going to be working by myself. So I need to position the jib over my work and have a little bit of flexibility of positioning my material. So this is what I come up with. This looks absolutely goofy. 2 arms by a pivot pin on each of them. This may not be strong enough, so we're going to overbuild it. Might have to worry about a way to pin it into place. But other than that, this is what I'm going to be building next. Let's try it.
It's time to move on to the pin sleeve. I'm using some 1/2-inch wall DOM tubing that measures about 2.5 inches inside diameter. The pin to sleeve clearance is way too tight. So I'm going to bring it to the lathe and open it up at about 20 thousandths of an inch. That's going to give me enough movement for some grease and to make this thing just pivot real nice and smooth. With the pin fitting perfect now, it's now time to address the gap between the sleeve and the tube itself. Way too big to weld, so I'm going to do some coping to shrink the distance. I'm doing a bevel cut and a cope at the same time with the cutting torch, and then a light little grind. This is really going to help with the welding. This little section of tubing is where the hook is going to hang from, so I'm going to make a relief cut in here, that way the hook can swing freely. One thing that nobody talks about owning a water jet or a plasma table or even a laser is the skeletons that come off these machines. I like to cut off the useful parts and then recycle the rest. In this piece you probably can recognize some past projects. I want to use some 3/4 inch plate to start making the hinge brackets. I made sure to get plenty of weld on this thing, that way I don't have to ever worry about it coming apart. The thicker the hinge sleeve really does help with the weld distortion when you go to weld it, that way the pin spins nice and freely and you don't have to go back and rebore it. I'd like to add a little end cap to this little jib piece, so I'm going to throw it in the blacksmith vise and bend it over to match the profile of the tube. No jib would be complete without a place to mount a hook or a clevis. So I'm going to use this piece of 3/4 cold roll round bar. We're going to bend it into U shape and then I'm going to weld it to the end of that little jib. I'm firing up the forge to heat it nice cherry red, and then I'm going to move it to the blacksmith vise and then bend a nice consistent U shape. Once I got the hoop welded on, I thought it'd be a good idea to weld on some washers on the top of the pin so they don't fall through. And then I want to drill some holes into the jib, that way I can position it wherever I want and then pin it so it doesn't move. These holes will correspond with the holes in the mainframe. The cool thing about this jib design is if I want to ditch those two little extensions off the end, I can. And make a special pin with a hook on it that can drop into the end of the jib. That way I have a nice short straight piece that looks pretty conventional.
This thing is ridiculous. It's kind of ugly, but it's going to be functional. I have these plates just tacked on, just in case I need to adjust the fit. This is going to be awkward to try to adjust. You're going to need a step ladder to try to push this tube in or pull it out. But I think I'm ready now to slip that jib in there and see how it works. Well, it went in. I'm happy with that. I think I'm okay with welding these saddles or hoops on permanently. So I'm going to do that next and then we'll try her out. This is so cool. The last piece of the puzzle. Come on, fit. There we go. I'm choosing to leave the grease out of the pin because I am curious how smooth it is in its worst condition. And I can always take these off and add grease zerks in it too if I need to. But I'm going to try to scoot the boom all the way back and then we'll pick something up with it. Yeah, yoo-hoo! So the idea behind this is that I'm able to position the hook over where I want something and then pick an object up and then kind of put it where I want. This allows me some in and out movement. Okay, let's lift up this piece of tube steel. I know this weighs approximately 300 pounds. This thing's gonna swing over because the forklift isn't positioned right. But I do have some movement at the top. So it moves. The load is right over the center. So I like that. Being able to get it where I need to go so it doesn't swing all over the place. That's one benefit. The next thing to do is get the load on the hook to see if we can move it. So let's try that. holds my weight. But I think I'm gonna grease it and try that, see how much better that makes the performance. But no matter what, this is gonna do what I need it to do. I just need to refine it a little bit. I can't wait to show you guys what I'm actually gonna use this for. Thank you guys for watching, and I'll see you guys when I use this thing in the next project. So see you soon.